Now that you've dealt with two-dimensional figures, we're going to go 3D. We are going to, instead of finding the areas of figures, we're actually going to be finding the volumes of figures, but we'll use a two-dimensional shape and turn it into a three-dimensional shape. So here you will notice we have the curve y equals the square root of x, which is being drawn, and then the next boundary is y equals 1/10 x, and I believe it's coming here pretty quickly. There we go. Alrighty, and then another boundary we're going to have is x equals 4. So you'll notice the vertical line x equals 4 is being drawn. And you can see that quite nicely. And now we're going to turn our paper. Now what we're going to do is we're rotating it about the x-axis. So notice it turned a two-dimensional shape into a three-dimensional shape. And now what we're going to do, especially when we do the disc method, we're going to pull different little discs out of there, and what we're going to do is find the area of each of those little discs, and then we're going to add all those areas together. Okay, so hopefully you're able to see that we're turning it into a three-dimensional figure. What we'll be able to do at the end of this lesson is find the volume of a solid of revolution by revolving a region around a line using the disc method. Okay, if you noticed in that video that we just watched, that created a disc. You can just think of like a disc, like a frisbee or something like that. It created a circular object. You will notice in that specific picture we actually had a hole in the middle, which would lead us to the washer method, but we're going to assume there's no hole in the middle, so we just have a bunch of discs. So basically what we're going to be doing is finding the area of a whole bunch of those circles. So if you remember, that figure kind of looked something like, actually I'll draw it down here, kind of looked something like this, and then when we revolve it, it revolved all the way around and then kind of looked like something like that. And then what we did, we just pulled out a circle and it made a whole bunch of circles, and we added those circles together. Okay, the formula for the volume of a disk is given by v equals pi times the integral r of x squared dx. Okay, if you notice, these are areas of circles, and you'll notice my formula for area of a circle is pi r squared. So the area of a circle formula is there. What the integral is going to do for us is add all of those circles together for us, add all those areas together. Okay, notice that this says r of x instead of just r, because our radius depends on what part of the curve the circle is at. So what we will do on this one is actually do that. The disc method is going to be used if you have a horizontal axis of revolution. So if we're revolving about the x-axis or about the line x equals 2 or anything like that, we will use the disc method. Okay, let's go ahead and try some examples. This first one says to find the volume of the solid formed by revolving the region bounded by the graphs of given about the x-axis. And I've given you a convenient window. So if you would like to take a minute on your calculator and graph it, and then come on back and I will show you what is going on with this. And actually we're out of order again, so we're just going to go with it here. Okay, when you do it, you should get a graph that looks something like that, and especially, whoops, x equals 3 goes right here. So the two-dimensional shape that we have is right here. So we're going to revolve it about the x-axis. So if I revolve about the x-axis, basically what's going to be happening, it's going to whirl around the x-axis, and I'll get something that looks similar to that on the other side. And hopefully, especially if you kind of look at it sideways, hopefully you're kind of seeing that that kind of looks like a Hershey Kiss. Okay, so what we're going to do to find the volume, it's always going to be pi, and then I need to go from what x value to what x value. It's going to go from 0 to 3. And then the radius, if I think of these circles right here, I'm pulling out a bunch of discs. The radius of that circle is dependent on where it's hitting this curve. So the radius is going to be cosine x plus 3/2, and then of course it's radius squared for a circle. And that would be my integral setup. And then from here, I will deem this one a calculator problem. So if you were to use your calculator, if you want to hit Math 9 right now, go ahead. When you do that, you should get a volume of 27.029. And that would be my formula. Alrighty, the next thing that I'm going to do is go to example. It's actually example 1 in your notes, and again I apologize for my numbering being off here. Okay, it says to find the volume of the solid formed by revolving the region bounded by the graphs of y equals the square root of 16 minus x squared and y equals 0 about the x-axis. So the first thing that we want to do is draw a picture. So 16 minus x squared is actually a half circle with a radius of 4. Okay, so that's what it looks like. And this is my region right here, and if we're revolving it about the x-axis, it kind of gets mirrored over on the other side. So we get this three-dimensional figure, and I believe that looks like an orange or a ball. Okay, so from here, now we're going to be finding the areas of a bunch of disks. So we'll use the disk method. We'll put volume equals pi. This figure is going to go from x equals -4 to x equals +4. And then what's forming the radius of those circles? The radius is being formed by this curve, the square root of 16 minus x squared. And then we have to square it because it's pi r squared. Okay, this one we are going to do non-calculator. So when I do this problem, we're going to have pi. When you square a square root, we'll just end up actually getting 16 minus x squared. And then since there's a minus sign here, we can take the integral of each part separately. And I'm just going to kind of stick that pi out front, trying to remember that I'm going to deal with it later. So my integral will be 16x minus 1/3 x cubed. And then we get to evaluate it at -4 and 4. If I plug in 4 into this equation, I'll get 64. And again, I'm just going to kind of keep that pi hanging out front for a little while here. 64 minus 64/3. And then minus, if I plug -4 in, I will get -64 plus 64/3. Okay, and then if I evaluate that, I'm going to get a common denominator. That will be 192/3 minus 64/3. And if I subtract that, I will get 128/3. And then minus, if I do the same thing with this one, it's going to be -192/3 plus 64/3. I'll get minus -128/3. And then if I add those two together, I will get 256/3, but I have this pi hanging out, so I need to make sure I include that. So that would be the volume of that figure that I just created. Okay, the next one that we want to do is, oops, don't want to do that one. I'm actually going to do example 4 next. Find the volume of the solid generated by revolving the region bounded by the graphs of y equals 2x squared, y equals 0, and x equals 2 about the x-axis. So once again, let's go ahead and graph y equals 2x squared, which is going to look something like this, parabola. We have y equals 0, and we have x equals 2. So it's not going to be a really big figure right there. Whoops. Okay, so we're going to revolve it about the x-axis. We're going to spin it about the x-axis, and when I do that, I get a figure that looks like that. And if you can think three-dimensionally on this one, I think it looks like a chocolate chip. Hopefully you think it does too. All right, so to find the volume of this, we're going to take pi, and it's going to go from x equals 0 to x equals 2. And then we will have the radius. The radius of that circle is going to, of our disks, are going to depend on 2x squared. So we'll have 2x squared dx. And let's do this one non-calculator also. So we'll have pi. 2x squared will be 4x to the 4th. Don't forget you have to square the 2 and the x squared. And then I'm ready to take the integral, so I'll get my volume will equal. Again, I'm just let that pi hang out there for a little bit. This will be 1 or 4/5 x to the 5th, and then we're going to evaluate it at 0 and 2. If I plug in 2, I will end up getting 128/5. We've still got that pi hanging on. And then if I subtract, when I plug in 0, I just get 0. So multiplying that out, I will get 128/5 pi, and that will be the volume of that little figure that I just found. Okay, last example. Find the volume of the solid formed by revolving the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1 this time. Okay, so if you want to take a minute on your calculator and do this, that would be wonderful. So I know that it's going to be a parabola opening down. And we're also going to do g of x equals 1. So g of x equals 1 is a vertical line. So it's going to be this little shape right here. And notice this time we're not revolving it about the x-axis, we're revolving it about the line y equals 1. So this shape right here is going to go about the line y equals 1. So when I do this, it's just going to kind of end up, we're going to get a shape that looks something like that. And in my opinion, I think that shape kind of looks like an M&M when we look at it. So hopefully you think it does too. Alrighty, so getting the volume, we're going to have volume equals pi. Now one thing, when you use the disk method is depending on us going about the x-axis. Okay, so you'll notice right now we're going about the line y equals 1. So what we're going to do, we need to move the graph down to the y-axis, to the x-axis, excuse me. Okay, so we're just going to move this entire picture down. So what we're going to do when we do, we'll have volume equals pi. It's still going to go from an x value to an x value. And actually to figure that out, we need to find the point of intersection. So I'm going to take 2 minus x squared, and I'll set it equal to 1. And let's see, we'll subtract 1 from both sides. So we'll get negative x squared equals negative 1. So x squared will equal 1. So x will equal plus or minus 1. So I'm going to go from negative 1 to 1. And then my figure, the radius of the circle is depending on it hitting the top of that curve. So we are going to do 2 minus x squared, but we need to move everything down to the x-axis. So right now it's at the line y equals 1. We're just going to move it down 1 step. So it's on the y-axis. If it was y equals 3, we would subtract 3. If it was y equals 7, we would subtract 7. And then that will be squared still. And I'm just going to simplify that just a little bit. So we'll go from negative 1 to 1. If I just combine like terms in there, I'll get 1 minus x squared dx. And I think we'll let our calculator do the work this time. So if you want to grab your calculator out and try Math 9 on this, that would be great. When you do get an answer, it should be 3.351. So that would be the volume of that M&M. So hopefully now you can find the volume of a two-dimensional region by revolving it about a horizontal axis using the disk method.